Starting with the class 12th organic chemistry. The first chapter of organic chemistry is haloalkanes and haloarenes. So what are haloalkanes and haloarenes? If we take an alkane, alkane is represented by RH. R is for alkyl group, and if to alkyl group we add hydrogen, that becomes an alkane, because we have done from alkanes, if we take out one hydrogen atom, that becomes alkyl. And if we add H to that alkyl, again what we get is an alkane. So alkane, from alkanes, if we remove the hydrogen atom, one or more than one hydrogen atom, and in place of that we add halogen atom. X is the general symbol for halogens, that is for the fluoro, chloro, bromo and iodo. So X can be fluoro, chloro, bromo or iodo group. In general for these we are using a symbol X. So alkane, if we remove the hydrogen atom from this, one or more than one hydrogen atom, and substitute that by the halogen atom. So H we are moving, and in place of H, X is coming. This becomes an haloalkane. This compound is called an haloalkane. And we know this is benzene. From benzene, at all these positions we have CH. So one hydrogen atom is here. So if we replace one of the hydrogen atoms here of benzene by halogen atom, then this is called haloarene. This compound is called haloarene. So X can be again FCl, Br or I. If F is here, this becomes fluorobenzene. If Cl is here, this becomes chlorobenzene. So in general now we know what are haloalkanes and what are haloarenes, how we get haloalkanes and how we get haloarenes. Our first topic now is classification of haloalkanes and haloarenes. So first classification we have on the basis of number of halogen atoms. How many halogen atoms are there in haloalkanes and haloarenes? On the basis of this, they are divided into mono haloalkanes. From the name itself, it is clear mono means one halogen atom in alkanes. So they have only one halogen atom. For example, this is ethane. So one hydrogen atom from here we remove, and what we get is CH3CH2, and in place of that hydrogen atom, if I put a halogen Cl. So only one halogen atom is here. That is why this is called monohaloalkane. Now after monohaloalkanes, second type is dihaloalkanes. Two halogen atoms in alkanes. So if we are taking again ethane, removing one hydrogen atom from this carbon and removing one hydrogen atom from this carbon, this becomes CH2 and CH2 after removal of one hydrogen from here. And in place of that hydrogen, I am putting up the halogen Cl here. Since there are two halogen atoms, this is called dihaloalkane. Third type, polyhaloalkanes. Now poly means many. If more than two halogen atoms are there, that is called polyhaloalkane. Propane, one hydrogen atom from each carbon. If we remove, we are getting CH2, CH and CH2 with removal of one hydrogen atom from all carbon atoms. And in place of that hydrogen atom, we are putting up the halogen atom Cl. So more than two halogen atoms are here. So this is called polyhaloalkane. Second type of classification now. First classification was based on number of halogen atoms. Now second is haloalkanes. They are also classified as primary, secondary or tertiary according to the nature of carbon to which halogen is attached. To which carbon halogen is attached, whether that carbon is primary, secondary or it is a tertiary carbon atom. For example, the carbon atom this is a primary carbon atom. Why this is primary carbon atom? Because this is linking further with only one carbon atom. Even this carbon is primary because it is linking further only with one carbon atom. While this carbon atom is secondary because this links up with the two carbon atoms further. So based on halogen is linking with which carbon atom, primary, secondary or tertiary, they are classified as primary haloalkanes, secondary haloalkanes or tertiary haloalkanes. Like in this case, we have taken out one hydrogen from this primary carbon, and in place of that hydrogen, if we put a halogen, then this haloalkane is called primary haloalkane since halogen atom is linking to primary carbon atom in this case. Similarly, this carbon atom is secondary carbon atom because this links further with two carbon atoms. Taken out one hydrogen from here. In place of that hydrogen, if we put a halogen, this is called secondary haloalkane because halogen is linking to which carbon atom? Secondary carbon atom. Third is tertiary haloalkane. Now this carbon atom is tertiary because it is linking with three carbon atoms. Now that hydrogen that is taken out from here, in place of that we put a halogen atom. Since halogen is linking to tertiary carbon atom, this is an example of tertiary haloalkane. So there is a second classification, that is haloalkanes can be classified as primary, secondary and tertiary based on the halogen atom linking with which carbon atom. Now the third type of classification here is they are also classified as, different terms are here now, allylic haloalkane. Allylic haloalkanes. To know what are allylic haloalkanes, first of all we should know what is allylic carbon atom. Now a carbon atom which is next to double bond carbon atom. A carbon next to double bond carbon atom is called allylic carbon atom. And if halogen links to this carbon atom, to allylic carbon atom, that haloalkane is known as allylic haloalkane. If the halogen links to which carbon atom? The carbon that is next to the double bond allylic carbon atom. After knowing what are allylic haloalkanes, we are moving on to the second type here, vinylic halides or vinylic haloalkanes. Now again, to know what are vinylic haloalkanes, we should know first of all what is vinylic carbon atom. The double bonded carbon atom, both these carbon atoms which have a double bond, these are vinylic carbon atoms. I am taking this carbon atom, this is vinylic carbon, and to this if we link a halogen atom, that becomes a vinylic halide. Halogen linking to vinylic carbon. Vinylic carbon is a carbon that has a double bond. One more example. There is a double bond here in this cyclic compound. To this carbon atom, if we attach halogen atom, this also becomes vinylic halide. Third is benzylic halide. Now again, to know benzylic halide, we should know what is benzylic carbon atom. In aromatic compounds which have a benzene ring, this is benzene. The carbon which is next to benzene ring, the carbon next to benzene ring, this is called benzylic carbon. This is benzylic carbon. And to this carbon, if we attach a halogen, that becomes benzylic halide. Last is aryl halides. This is arene or aromatic compound, and directly to this if we attach halogen, that becomes arylic halide. So this is a classification of the haloalkanes and haloarenes. There are three ways to classify them. First classification is based on number of halogen atoms. Second classification is based on halogen is linking to which carbon, primary, secondary or tertiary. Then the third classification is allylic haloalkanes, vinylic, benzylic and the aryl halides. After knowing the classification of haloalkanes and haloarenes, our next topic is nomenclature. Naming of haloalkanes and haloarenes. How we'll name them? So we are doing the IUPAC nomenclature of these compounds, but for some of these we should also know their common names. First compound I am taking is CH3, CH2, CH2 and putting a Br here. Now IUPAC name of this compound. Numbering, we start from the carbon atom which has halogen. So there are three carbon atoms here. First we write the name of the substituent, that is the Br. So with first carbon Br is linking, this compound is called 1-bromo, and then how many carbon atoms in parent chain? 3. So this is called 1-bromopropane. 1-bromopropane. And common name is N-propyl bromide. N is normal. Normal means all carbon atoms are in a straight chain. The common name of haloalkanes is written from a word alkyl halide. First we write the alkyl and then we write the halide term. So first is alkyl and then is the halide here. Second compound, in this case this is parent chain, numbering from any side because this halogen gets the second position from both the sides. So name of this compound is 2-chloropropane. 2-chloropropane. And common name now here is, since Cl is linking to the secondary carbon atom, so this should be secondary propyl chloride, but for this normally we write iso prefix in place of secondary. So both these names are correct, secondary propyl chloride or isopropyl chloride. So when there are 3 carbon atoms, only 2 possibilities are there for the common name prefix. Either normal will come or iso will come before an alkyl group. Normal if all 3 carbon atoms are in straight chain. If we have the substituent or the halogen linking with the secondary carbon atom, then we use a prefix secondary or iso here. Third example. Now since halogen is linking with this carbon atom, this has to be there in the parent chain. This carbon has to be in the parent chain. So this becomes a substituent and this is also a substituent. The lowest sum we are getting from this side, numbering from this side. Now the substituent's name has to be written in an alphabetical order. So for this compound we write 1-chloro. Since C will come first in alphabetical order, we write chloro first. 1-chloro and 2 is which substituent? Methyl. 1-chloro, 2-methyl, and then in the chain there are 3 carbon atoms, so it is 1-chloro, 3-methyl propane. Now common name of this compound, there are 4 carbon atoms here and the halogen is linking to the primary carbon atom, but we have one alkyl group in the branching, so this is called isobutyl. 4 carbon atoms are here, so alkyl is butyl. Isobutyl chloride. This group CH3, CH2, this group is known as isobutyl group. Name of this group is isobutyl. And if in the 4 carbon atoms, we have all 4 carbon atoms in straight chain and from here we remove hydrogen atom, all 4 carbon atoms in straight chain, this is called normal butyl group. Which group is this? Normal butyl group. And in 4 carbon atoms, if we have 4 carbon atoms in straight chain, but substituent is linking to this carbon. Since substituent is linking with secondary carbon atom, this is called secondary butyl group. So for common names, actually we should know about these groups. There's one more group when we have the 4 carbon atoms, isonormal butyl, secondary butyl. The fourth type is if there are 4 carbon atoms in alkyl group, like this, and halogen links with this tertiary carbon atom, halogen is linking with the tertiary carbon atom, then this is called tertiary butyl. If just leave this group, only this group is here, this is called which group? Tertiary butyl group. So when there are 4 carbon atoms, how these carbon atoms can arrange? If all carbon atoms are arranging in a straight and substituent is linking with the straight carbon, it's normal butyl group. If we have the group linking with a secondary carbon atom, it's secondary butyl. If group links with a primary carbon, but one carbon in branching, it's isobutyl group. And if the group links with a tertiary carbon atom here, total 4 carbon atoms are here, but arrangement is like this, that group is linking with the tertiary carbon, this is called tertiary butyl group. So common names, we should know about these prefixes: normal, iso, secondary and tertiary. So moving on to the next example, 3 examples we have covered up for nomenclature. 4th example. If we have this compound, we know this is known as bromobenzene. Bromobenzene, its common name as well as its IUPAC name. It's used in both. Next example, we are taking 3 halogens here in this case. So name of this compound, this is your first carbon, this is second, this is third, this is fourth. This is 1, 3, 4 tribromobenzene. Next we have this compound. We have to do only its IUPAC name. So this is a parent chain. In this case, how many carbon atom maximum we can get in any chain is 3 carbon atom. This way, or we go this way, or we go this way. Maximum there will be how many carbon atoms? Just 3 carbon atoms will be here. That means these 3 are our substituents. Now numbering, we are doing it from this side, because from this side we'll get the lowest sum. Now name of this compound, write the name of substituents in alphabetical order. So first will be chloro. Chloro is attached to first carbon atom, 1 chloro. Then with second carbon atom, we have 2 alkyl groups, that is methyl group. So it is 2, 2 dimethyl. And then is the name of the parent chain, that is propane. So IUPAC name of this compound is 1-chloro-2,2-dimethyl propane. Next example. If we expand this compound, it's actually like this. With this carbon, 2 halogens, 2 Cl atoms are linked with the same carbon atom. So this is a parent chain. Numbering from this carbon atom, and name of this compound is, since with the first carbon atom 2 halogens are there, so it is 1, 1 dichloro, and in parent chain 2 carbon atoms are here, so this is ethane. This is the IUPAC name of this compound, that is 1, 1 dichloroethane. Next example. If we attach 2 halogen atoms with different carbon atoms, then this is a parent chain, numbering from any side. So 2 halogens, one is linking with the first carbon atom, one is linking with the second carbon atom. So it is 1, 2 dichloro, and then parent chain, how many carbon atoms are here? 2 carbon atoms, so this one is 1, 2 dichloroethane. Moving on to the next example, CH3CHCl, this compound. Now this is a parent chain, but now numbering will do it from the left side, because this side will give the lowest number to this halogen attached. Name of this compound, with second carbon atom, there is Cl, so it is 2 chloro. After that, parent chain 4 carbon atoms are here, so this compound is 2-chlorobutane. This compound is called 2-chlorobutane. And what is the IUPAC name? What is the common name of this compound? Since halogen is linking to secondary carbon atom, so this is called secondary butyl. Since it's a common name, first we write the name of alkyl, secondary butyl, and then is chloride. This is a common name of this compound. And then we have done that this group is called tertiary butyl group. This group is a tertiary butyl group, and with this tertiary carbon, if we attach halogen, this is called common name tertiary butyl chloride. This is the common name of this compound. And for IUPAC name of this compound, the parent chain will have 3 carbon atoms. Maximum there will be 3 carbon atoms in this chain. Either we can take this or we can take this way. And numbering from here, or we can start from the numbering from this carbon atom 1, 2, 3. This halogen will get the second position only. So these two substituents are left. Write the name of this one in an alphabetical order. First will be Cl and then will be CH3. So with second carbon we have chloro, and with second carbon only we have methyl group. So it is 2-chloro 2-methyl. Then come to the parent chain. There are how many carbon atoms? 3 carbon atoms. So this becomes 2-chloro 2-methyl propane. Next example. CH3 whole thrice C CH2Br. Now how to expand the formula? CH3 whole thrice C. With this carbon, 3 CH3 groups are attached. With this carbon atom, 3 sides what we have are CH3 groups. Then next to this carbon is CH2, and next to CH2 is Br. This is how we'll expand this formula. Now parent chain is this. Maximum we can have 3 carbon atoms only, and these 3 will become the substituents. Numbering will do it from this side, because this side the sum will come out to be lowest. Now write the name, IUPAC name of substituents first of all in an alphabetical order. First will be bromo, that is attached to first carbon atom, 1 bromo. Then come to the second carbon atom. There are 2 methyl groups here. So 2, 2 dimethyl. Then come to the parent chain. 3 carbon atoms are here. So this is propane. So IUPAC name of this compound is 1-bromo 2,2-dimethyl propane. Next example. This compound. Now here we have 2 carbon atoms only in a parent chain, and this carbon halogen is linking. Numbering from halogen side. Name of this compound, IUPAC name, 1-chloro, and then 2 carbon atoms in chain eth. Since there is double bond, so we'll write ene here. 1-chloro ethene is IUPAC name of this compound. Now common name of this compound, this group, leave this halogen, this group we know is called the, which group? Vinyl. This is vinyl carbon, double bonded carbon atom. With vinyl carbon, Cl is linking. So this compound is called vinyl chloride. This is a common name of this compound, vinyl chloride. Actually this group CH2, double bond CH, this group is called vinyl group. With vinyl, Cl is attached. So this compound becomes vinyl chloride. Next example. IUPAC name of this compound. This is our parent chain. Numbering from halogen side. Numbering now will be from the double bonded side, because If substituent and double bond is here, then the preference is given to the double bond. To the multiple bond will give the preference. So numbering will be now from the double bond side. It should get the lowest number. So halogen is attached to the third carbon atom here. So its IUPAC name is 3-bromo. Then 3 carbon atoms are here in a chain. So we write prop for this. And since there is a double bond, so we write ene here. 3-bromo propene. Common name of this compound. This carbon that is next to double bond is allyl carbon. To allyl carbon we have this halogen linking. So this group actually is called which group? Allyl group. To allyl group halogen is linking. So this compound common name is allyl bromide. Common name of this compound is allyl bromide. Next example. IUPAC name of this compound. Now there are two substituents, chloro and methyl. Numbering will do it in an alphabetical order since both these are the substituents only. So numbering we are doing it from the chloro side. 1, 2. So this becomes 1 chloro, 2 methyl. These two are attached with benzene. So this is benzene. 1 chloro, 2 methyl benzene. Or there's another name for this. This compound, if we have just this compound, this is called toluene. This compound is called toluene. In toluene, there is a Cl group attached here. To toluene, Cl is attached. If this is toluene, the numbering will be from here. So this is now 2-chlorotoluene. 2-chlorotoluene. Both these names we can use in IUPAC nomenclature. Next, very important example. We have done that this carbon is benzyl carbon, the carbon next to the benzene ring. To this carbon, Cl is attached. What we are linking here is the Cl. Now since this is the benzyl group, this group is called which group? Benzyl. This is called benzyl group. To benzyl group there is a halogen attached here. So name of this compound is benzyl chloride. This is used in IUPAC as well as in the common name. In both we are taking the benzyl chloride term. In IUPAC nomenclature we can also write the name of this compound as, this is a parent chain here because with this the substituent is linking. So this is a main part, only one carbon atom. With this carbon only, one substituent attached is Cl. Another substituent, this substituent is phenyl. When from benzene, one hydrogen is removed, that is called phenyl group. So with this carbon, substituent chloro and phenyl are linked. Write the name of these substituents in an alphabetical order. So first will be the chloro, 1 chloro, and then will be the phenyl, 1 phenyl. And since only one carbon atom is here, so this is methane. So we can also write the IUPAC name of this compound as 1 chloro, 1 phenyl methane. But most commonly used is the benzyl chloride, which is used both in common as well as in IUPAC nomenclature. Next example. With one carbon, first carbon only, there's only one carbon atom, 2 halogens are attached. So this is called 2 halogens are linking with this only. This is 1, 1 dichloro. With first carbon only we have 2 chloro groups, so 1, 1 dichloro, and one carbon in parent chain, we write methane for this. This is the IUPAC nomenclature of this compound. Now, common name of this compound is methylene dichloride. This group is called methylene group. This group is called which group? Methylene group. So this is methylene dichloride. Next is the, now with one carbon atom, 3 halogens are attached. So this becomes 1, 1, 1 trichloromethane. Its common name is important, that is chloroform. This compound is called chloroform. And if in place of Cl we have Br here, CHBr3, IUPAC name 1, 1, 1 tribromomethane. And its common name is bromoform. This is called bromoform. Next is CCl4. Now all hydrogens of methane are replaced by the Cl. This becomes 1, 1, 1, 1 tetrachloromethane. And commonly we are using a term carbon tetrachloride for this. This is commonly known as carbon tetrachloride. Last example is now in this compound there are 3 carbon atoms in a chain and one substituent is F, numbering from this side. So name of this compound is 1-fluoropropane. And what is its common name? Since all carbon atoms are in straight chain, this is N-propyl because there are 3 carbon atoms here. N-propyl, and then is the name of this halogen, which is fluoride. So common name of this compound is N-propyl fluoride. So these are some examples for the nomenclature of haloalkanes and haloarenes.